So we're going to talk about ionic compounds first. So we've already talked about how to predict the charges for some of the ions. The metals in group 1A all form a positive 1 ion. The metals in group 2A all form a positive 2 ion. And in group 3A form a positive 3 ion. Remember that? There's two other ones, zinc and silver, and these you have to memorize. Zinc is always +2, silver is always +1. I can't explain that to you in the amount of time we have. Nonmetals. The nonmetals we learned, you can find the charge by saying it's the group number -8. Most students don't really like that much. Or we said we were playing a really weird board game and we're starting on the far right column as 0 and counting backwards till we get to the element, and that would be the charge. So that's a review. In an ionic compound, you always have to have a positive ion and a negative ion, because otherwise there'll be no attraction and you won't have a compound. When we write the chemical formula, the total of positive charges has to equal the total of the negative charges. Overall, the formula for a compound is neutral. It has charged things in it, but the formula overall is neutral. So when we're writing formulas for ionic compounds, we first write the symbol for each of the ions. You're going to have one that's positive and one that's negative. You need to write their symbols, include the charges. And then we figure out how to put them together. Do we need 2 of this one and 3 of that? What do we need so that when we lump them all together, their charges add up to 0? There's a couple different methods for that. One of them is the crisscross method. We always want to have the ratio of the subscripts to be the smallest whole number ratio. And it's always a good idea to check when you're done that all the charges add up to 0. So let's do some examples. Write a formula for the compound that forms from strontium and chlorine. Well, first we have to find the symbols for strontium. Strontium is Sr, chlorine is Cl. I always make my lowercase l's as a script L because, what's that? Could be a 1, could be a capital I, could be a lowercase l. It's pretty confusing. I make my capital I's with bars on the top. I make my lowercase l's like this. And if I'm going to make a 1, that's just a line. Unfortunately, the font that I chose for these PowerPoint slides, they all look the same. Next time I'm going to change that. Anyway, what group is strontium in on the periodic table? What column? 2A. So that tells us what the charge is. 2+. So its formula is Sr with a 2+ superscript. Yes?
So if we're looking at carbon, it would be 2, 5, 4?
So, yeah, we haven't talked about carbon. Carbon actually doesn't form ions much at all. And in this class, it never forms ions.
Well, how do you just look at the group that it's in?
So this is a metal in group 1, group 1A, and I'm sorry, 2A, group 2A. All of the metals in group 2A form 2+ ions. And all of the metals in group 3A that we'll ever run into form 3+ ions. I have a hard time lying, so I stick these qualifying things in. Group 1A metals form +1 ions.
How do we know if it's a negative?
Non-metals form negative ions. So if it's a non-metal, if it's on the right side of the line, it'll be a negative ion. If it's on the left, it'll be positive.
So Cl would be
Negative.
2.
Not -2. So let me draw a little piece of the periodic table here. So here's argon, and here's chlorine right next to it. So this is group 8, and this is group 7. There's stuff around it. But to determine the charge on chlorine, we start with the noble gas as 0. The noble gases don't form ions. They are always just neutral atoms. So this is 0, and then we're counting backwards, -1. So chlorine's -1. If we continued on to sulfur, it would be -2.
And when does it transition to positive?
Well, the guys in the middle just don't do it, and so if you just follow the pattern, I'm never going to ask you to make an ion for silicon, because it doesn't do it. So you don't need to know that it doesn't do it, because I will never ask you to do it. Question? Just stretching. It's a good idea. Get the blood flowing. Yes?
So boron will be -3 still, because it goes to negative 1, 2, 3.
So boron is also there in the middle where it just doesn't really form ions.
So it just kind of stops, it will just go, it will stop at -3 then? Like -1, 2?
Pretty much, yeah.
Okay.
And I know that's disturbing to some people. What about those guys in the middle? Okay, well, if you had to, just follow the same pattern. Just keep going, -3, -4, -5. I'm just never going to ask you to do it. Yeah. Okay, so we have the ions and their charges. We need to figure out how to put these together so that all their charges add up to 0. If we have one strontium ion and one chlorine ion, 2 plus and -1 is going to add up to 1 plus, right? That's not going to work. So we're going to need 2 chloride ions. Each of these has a -1 charge. If we have 2 of those, the total is a -2 charge, -1 from each. And if I have one strontium ion, I have a total of +2 charge. And I think we can all tell that +2 and -2 add up to 0. Okay?
So we just put a 2 in front of Cl negative thing?
No, we don't want to put a 2 in front of it. When we make the formula, we do not include the charges. I think because it would make things very cluttered, and it's also not necessary. Our formulas, we try to make them very concise. We don't want to put a whole bunch of extra stuff in there because it makes things even more complicated. To write the formula, we say I need 1 strontium and I need 2 of these. And so I'm going to have strontium without a subscript, because we understand that would be a 1. And then I'm going to write the symbol for chlorine, and I'm going to put a subscript 2 to indicate that there's 2 of them. Yes?
I'm sorry, can you clarify, how do you know chlorine has a negative charge? Because nonmetals tend to gain...
Nonmetals gain electrons. Electrons have negative charges. If you're gaining negative charges, then you're going to have a negative charge.
So, like, the charge is after it's gained, not just as it is now?
Well, there are chlorine atoms. They tend to go around in pairs as chlorine molecules. And those are not going to have a charge. Chlorine ions will have a -1 charge, always. And we will understand in a future chapter why they form -1 ions. For now, we're just learning what they do. Yeah?
Does that have to do with like the rings and whatnot?
It does have to do with the rings and whatnot. Yeah. So, do you see how I took these 2 things and figured out that I need 2 of these?
Yes.
Okay? So this is the more understanding what's going on method, which I think is the best method. But I'm willing to settle for getting it done being right most of the time. You know, it'd be great to be right all the time, but being right most of the time is pretty good. So I'm just going to make a little space over here and show you the method that is a favorite of students. I'll maybe do this in a different color. You still need the ions with their charges. Whoops, yeah, that's right. This is called the crisscross method. Before you crisscross, look at the charges. This is 2, and that's a 1. They're not the same. We can crisscross. If they're the same, you don't need to. So what crisscross does is it takes this 2, and it says that is the subscript for the other ion. The number here, the number 1, which isn't written, is going to become the number 1, which isn't written, as the subscript on the strontium. So we get SR unwritten 1, Cl2. That's going to get you the correct answer probably 90 to 95% of the time.
Why not 100%?
That's a good question. Why not 100%? Because sometimes you could have something like SN 4 plus and O 2 minus. These charges are not the same, so I said we could crisscross. Take the 4 down here, take the 2 down there. SN2O4. Is 2 to 4 the lowest ratio? No. So this would not be correct. If you're on top of things and say, oh, shoot, that's not the... That came out just like... I grew up in Minnesota. Oh, shoot. Sorry. 2 to 4. You say, oh, shoot, that's not the lowest ratio. I should simplify that. It's going to be SNO2. Then you'll be okay. But if you just blindly crisscross, you can end up with an incorrect answer once in a while. If you do the understanding method with this one, here I've got plus 4 and I've got minus 2. I need 2 of these to balance the charge on the plus 4. I need 2 negative 2's to cancel out the positive 4. And so you can reason it out this way. If you're good with least common multiples, that's essentially what we're doing. Okay? This tends to be confusing for students. It is not hard math. It's just strange and different. And so you just have to keep at it until it clicks, and then you're like, oh, well, duh. You do problems like this all the time in real life, but they involve, like, distributing cookies to your friends or sharing slices of pizza or something.
So why, if it was like -2, why did you write that one? We don't write the negative?
No. No, you don't write the negative. So we don't want to say SN -2, because that would say we have -2 tin atoms or ions, and you can't have -2 ions. The crisscross thing is like a cheat, a hack.
We write the charges on top, like keep the charges with it.
So when you write the formula for the compound, you don't write the charges. So let's see what that would look like if we did that. So we'd get SN 4 plus O2 2 minus. Things are getting very cluttered, right? And this becomes really difficult to type into a computer, for one thing. It's just, and it's not necessary, because a chemist looking at SNO2, I can tell you what the charges are. I don't need them to be written here. The reason we're writing the charges here is because we have to consider them when we figure out how many ions to put together. And beginning chemistry students are not good at just having a imaginary whiteboard in your mind. It tends to like disappear on you when a squirrel runs by, right? You need to actually write it down on a piece of paper so that you can see it. Let's do another example. Write the formula for the compound that forms from aluminum and nitrogen. Well, the symbol for aluminum is Al. That's the metal. That's the element Al. What group is Al in? Al's in group 3A. That tells us what the charge is. It's 3 plus.
Whoa, I thought we were on the negative side. I thought you said that it was the
Okay, so I did say that the metals, the elements that are touching that line are semimetals, except aluminum. Aluminum is a metal. It's not a semimetal. The other thing, it's not in the textbook, but what I've noticed is for the semimetals, they fall into non-metal and metal categories for naming things. So silicon is a semi-metal, but in terms of naming things, we're going to consider it a non-metal. So aluminum is right up next to that stair-step line, but it's on the metal side. Metals form positive ions, and in group 3A, which is where it is, they form a +3. Okay? Now what about nitrogen? -3. So we look at nitrogen on the periodic table, and we go over to the far right where neon is. Neon's going to be 0. We go 1 square to the left. Fluorine is going to be -1. We go 1 more to the left. Oxygen is going to be -2, and nitrogen is going to be -3. There's a reason they do that, but the pattern is pretty nice. And right now we're just going to use the pattern. So N3-. So now we've got our ions with their charges. Are these numbers the same? Yep. They're opposite in sign, that's always going to happen, but we've got +3 and -3. We don't want to crisscross, we don't even need to think about anything, we're just going to push them together. ALN. We only need one of each. It's a 1-to-1 ratio. Yes?
Determine aluminum because its position can be so confusing. Can you just trace back to the last noble gas to find that it was one?
No, you could look at how many valence electrons does aluminum have. It has 3 valence electrons. It's going to lose all 3 valence electrons to have the same number of electrons as neon, and that's why it forms a +3 ion.
Yeah, that's okay.
Yeah. I thought you meant counting back from the other side.
Well, just looking, by counting back, are you looking at the nearest noble gas?
As in losing electrons? Because you can't talk about aluminum going to the right to become like argon. Aluminum would go left. Magnesium, sodium, neon. I really think at this point it's simpler. Group 1A +1. Group 2A +2. Group 3A +3.
But like borons is 3A, so you would consider
It's not a metal.
a non-metal.
It's not a metal. The other thing about boron is I'm never going to ask you to write a formula for a compound with boron because it's weird. It's a weird element. Breaks all sorts of rules. It's no fun. Yeah.
Okay, so when you're counting, you go from 1A, 2A to 3A, that's positive.
Yep.
And then you go from next to the nobles to
You count backwards.
nitrogen to negative.
Mhm.
1 to 3. Okay.
Yeah, and it's just a trick. I try to find patterns because I have a hard time remembering stuff too. I can't remember my kids' names. That's why it'll be a miracle if I remember your names. They come up to me and I'm like, I know you're my kid. You look like all the others, but who are you? So there's deep understanding of why they do what they do, and that's great. But bottom line, we just need to be able to predict what they do. And so that's the counting backwards. Okay. Okay, I mentioned polyatomic ions. We talked about that briefly with the parentheses. So poly is a prefix that means many atoms. Many atoms. So these are ions that are groups of atoms. They're stuck together, super glued together, if you will, and they have an overall charge together. These have special names. Their formulas, like carbonate has this formula, CO3 2-. There are scientific reasons why its formula is like that. Do we need to know them? No, we don't. The fact is that ions with this formula exist in nature, and we have chosen to call them carbonate. So why is it called carbonate? Because a bunch of smart people decided and agreed that that's what we're going to call them. You know, why is my oldest son called James? Because his father and I decided to name him that. So some students are like, but why? But why? It's because we just decided. Okay? I'm sorry, there's nothing better than that. So these are their formulas and these are the names. So how do you know them? You memorize them. Do you have to memorize all of these to be successful in my Chem 3A class? No, you don't have to memorize all of them. Okay, I put a list on Canvas on the syllabus page. Those are the ones you do have to memorize. Make some flashcards. Will they be on the first exam on chapters 1 through 4? No. They'll be on the second exam on chapters 5 through whatever, because this is chapter 5. Okay?
We're having a quiz every Monday.
We're having exams every Monday. I know quiz sounds friendlier, but I think, I don't know that anybody would say that the exams are friendly. They're not brutal. I haven't made anybody cry in class.
I don't think so.
No. So the thing about 50 questions, I know that sounds horrible. The thing is, when you have fewer questions, it becomes way more, I mean, if you only have 10 questions and you miss 2, right? You're down to 80%. If you have 50 questions and you miss 2, you're at 96%.
Or like, if you miss 20 questions, what is that?
Then you're at 60%. Then you're at 60%, yeah. But the thing is, you can know your stuff. You can have studied and know the stuff, and you're still going to make what you later consider to be stupid mistakes. You're like, oh man, I knew that one, and why did I bubble in the wrong letter? Right? Stuff like that. Kind of just random brain fart mistakes, right? So on a smaller test, fewer questions, those are going to have a huge impact on your grade. When there's 50 questions, you could have a couple of those, and it's really not going to mess with your grade very much. A lot of those questions, you read them and you can answer them in 5 seconds. You know, what is the element symbol for carbon? It's not going to take you 5 minutes, right? If it does, there are some other issues, right? Yeah, the periodic table is going to be on the wall, and I'm going to give you a paper copy too, and you can write all over it. And you can write all over the exam. It will not have the names. It will not. So why am I making you memorize the names, right? Just to be mean? No, because if you don't memorize the names, you're going to waste so much time looking up which it is over and over and over again. And I'm just giving you the most common ones. Yeah.
We use our own.
You cannot use your own. Yeah. Nice try. Yeah. But I put a copy of the one I will give you on the syllabus page on Canvas. And so you can look at it and see what it's got on there, okay? It doesn't have the element names. Okay, so these need to be memorized. Let's look at them. And if we look at the charges, almost all of them are negative except this guy. This is that one exception. This is the only non-metal cation. And it's a polyatomic ion. Okay, so that's kind of a weird one. Most of the rest of these have oxygen in them. Do you see that? Oxygen, oxygen, oxygen. This one doesn't. This is cyanide. But most of them have oxygen. And then there are some that seem to fall into kind of a pattern. ClO minus, ClO2 minus, ClO3 minus, ClO4 minus. And their names are kind of similar too. Cl is chlorine, and these all have chlor in their name. I'm going to show you how that pattern works. Then we've got some, like this is called sulfite, and this is sulfite with an H on the front. So this is called hydrogen sulfite. The older name is bisulfite. You might run across that, but I won't ever put it on a test because I don't like that name. It's the old name, and I want to stick with this one. I think it's more descriptive too. Hydrogen sulfite. Okay? Yes?
For the ones that you wanted to remember, you wanted us to remember the name and the formula?
Name and the formula. And it's mostly the 8s. It's nitrate and chlorate and carbonate and acetate and phosphate and sulfate, hydroxide, ammonium. I think those are the ones. Okay, so we can write formulas for ionic compounds that have these polyatomic ions. So calcium ions and nitrate ions. So nitrate, see this ends in ATE. Let's go back to the table. Most of these names end in ite or ate. Nitrate is similar to the word nitrogen, but it's not exactly the same as it. So this is not just a nitrogen ion. It's nitrate ion. So for now, we're going to go look it up. Nitrate ion, NO3 with a negative charge. So we're going to do the same thing. We're going to write the two ions with their charges. We just looked up nitrate. It's NO3 with a -1 charge. What's the charge on a calcium ion? 2 plus. This is a metal. It's in group 2. It's +2. Now we have to figure out how to put these together. Well, look at the charges. This is 2 and this is 1. They're not the same. You could crisscross. You like crisscross? You want to do the other way? Do both ways. Sure, let's do both ways. Okay, let's do the thinking method first. So I'm just going to kind of keep a tally. So here I have +2 and I have -1. Those don't add up to 0. I need more negatives, right? So I'm going to add another ion. I can't change the charge of it. I can't have half of it. I can add another. So I'll just write another one in here, NO3. That one is also going to be -1. Now my total charge over here is -2. Oh, nice. +2, -2. It's good. I have 2 of these groups and 1 of that. So calcium, and I have NO3. I have 2 of them. So these polyatomic ions, those are those bundle packages that you get at Costco. I can't just write a 2 next to it because it looks like 32 oxygens and 1 nitrogen. That's not what I mean. I mean 2 of these groups. So I put parentheses like shrink wrap around it, and I put how many of those packages on the outside. The crisscross method, start with the same thing, Ca2 plus, NO3 minus. You take this 2, it's going to become the subscript for the NO3. You take this unwritten 1, that becomes the subscript for the calcium. So Ca, I don't know what happened there, Ca, NO3, I need parentheses, and a 2 on the outside. You don't want to write N2O6 because, well, for one thing, it looks weird. Might not look weird to you. This might look weird to you. We want to be very clear that the polyatomic ion, known as nitrate, with the formula NO3 minus, is the thing we're talking about here. And we learn to recognize it by its formula. We have 2 of these units. Okay? Any questions? Let's look at aluminum and phosphate ions. So here's our friend Al. What's the charge on an aluminum ion? 3 plus. Simply because it's in group 3. Group 3A. A metal in group 3A. Phosphate. Phosphate is phosphorus and oxygen. It's PO4 with a 3 minus charge. Why? Because I said so. Because it is. You memorize it. That's how you know it. Now, you can increase your chances of guessing if you're taking the exam 2 a week from Monday and you need phosphate and you're like, I'm blanking, I don't know what it is. Well, phosphate has phosphorus and oxygen in it. And all of these have negative charges, so you could take a stab in the dark and guess at how many oxygens and guess at the charge. It'd be probably better than nothing. Putting these 2 together, what do I need to do? Just put them together. Plus 3 minus 3. So this is AlPO4. Do I need parentheses? No. I don't want to write parentheses unless I absolutely have to. I will write parentheses if I have more than 1 polyatomic ion to avoid confusion. Here I just have 1 polyatomic ion. It kind of looks like a dog food, doesn't it? Alpo4. Good for your dog. Sodium and sulfite. What's the symbol for sodium? Na. Na. There's a whole bunch of jokes. Anyway, What's the charge on the sodium ion?
Plus one.
+1. It's in group 1. It's +1. Sulfite. Well, sulfur and oxygen. Right? Sulfite is SO3, 2 minus, because that's what it is. How do we put these two together? We're going to need 2 sodiums, so Na2, SO3. This unwritten 1 becomes the subscript for the sulfite. The 2 becomes the subscript for the sodium. Don't need parentheses here. I don't need parentheses around sodium because it's not a bundle pack. This is just an individual bottle of ketchup like you could buy at the grocery store. And I've got 2 of them. This is a package deal, but I've only got 1, so it's fine to just leave it there. Any questions?